Good morning, students. Here to start the session.
Morning, students. Good morning. How are you?
Good morning, sir.
Okay. So today we have to start with a new chapter, that is hydrocarbons. Okay. So we have to discuss about the hydrocarbon, their classification, and their preparation, physical properties, chemical properties, and then we'll go for uses and followed by the mechanisms of every preparation now. Okay. Those who are in our syllabus and those who are necessary will do that mechanism. The rest mechanism will not do. Okay. So if I talk about the hydrocarbons, as the name suggests, they are the compound which contain hydrogen and carbon. Hydrogen and carbon only. They are known as what? Hydrocarbon. So if I'll say about the hydrocarbon are considered as the parent organic compound. Why they are considered as parent organic compound? Just because all the other organic compounds, they are derived from the hydrocarbons by either replacement of one hydrogen, two hydrogen, three hydrogen. That's why we are saying it as that hydrocarbon is the parent organic compound. Okay. If I talk about the you can say from where we get these hydrocarbons. So generally, if I talk about this source, that source is majorly in the form of they are widely distributed in the form of petroleum, okay, natural gas, then you have coal, okay. So these are the natural sources from where we can get hydrocarbon very easily, okay. So generally, hydrocarbons have a different role and plays a very important role in our life and in our world. Approximately, you'll see everything around you contain carbon. Okay, so if you have heard LPG, what is the full form of LPG? What is the full form of LPG?
It should be for example.
Yeah, pardon. Again, just repeat it. LPG is liquefied petroleum gas. CNG is
Yes.
compressed natural gas. Okay, so these are used as fuel. They have carbon present, hydrocarbons in them. Gasoline, petrol, what we say gas, petrol, kerosene, diesel. They all are the product of distillation from the petroleum, crude oil. Okay, so generally we have to talk about these. Let's discover the classification of the organic compound. Okay, the classification I'll make here. If I'll classify the hydrocarbons are basically divided into the two categories. First category I'll say is as alicyclic or open chain. You can make side by side if you want, just because we'll discuss every part of the classification. One side I'm taking the alicyclic or open chain. A cyclic is also known as a ring chain. Okay. Alicyclic is classified into two categories again, that is saturated and unsaturated. Saturated contain alkanes which have single bond. Unsaturated contain alkenes and alkynes. Alkenes contain double bond, alkynes contain triple bond. Then cyclic is again classified into two categories. alicyclic and aromatic. Alicyclic, okay, this is acyclic, not alicyclic. This is acyclic. This is alicyclic. Okay, alicyclic is again classified into two categories. First one is saturated. It means when there is a ring and it contains only single bonds, that is a kind of cycloalkanes. You can say cycloalkanes. And unsaturated, again, two categories, cycloalkenes and cycloalkynes. Okay. Aromatic are again classified into two, benzenoid containing the benzene ring, non-benzenoid which do not contain benzene. So benzenoid compound are also known as arenes. So I think most of the term is clear just because we have learned the chapter, last chapter, organic one. So alicyclic, if I say alicyclic or open chain ring, I'm talking about the straight chain. Okay. Saturated, unsaturated, alkene, alkenes means single bonded compound, double bonded, triple bonded compound. We have already discussed in the last chapter. Cyclic or ring, it means those compounds which are forming a closed chain, that is called cyclic. While they are again classified into alicyclic and the aromatic. Alicyclic are the compound which contain only the carbon. Okay, the ring which is made up of carbon, and it is again classified into two categories, that is cycloalkanes having the single bond inside the ring. It means the ring have only the single bond, while unsaturated is classified into two categories, cycloalkenes which contain ring plus a double bond or a multiple double bond can be there. Unsaturated means triple bond must be there. Cyclic compound, if I say, cyclic compound have one more category, that is aromatic. And aromatic, we have done Huckel rule in the last class. What was the formula of Huckel rule? Yes, in the last chapter of organic, first chapter of organic, we have discussed the Huckel rule, aromatic compounds. It was 4n plus 2 equals to pi electron. Okay. Aromatic compound is again classified into two categories, benzenoid and non-benzenoid. Benzenoid which contain the benzene ring, while non-benzenoid which do not contain the benzene. So I don't think that this is quite tough. Okay. So we'll start with the first part of the chapter, that is we'll discuss about the alkanes. We'll discuss about the alkanes. This is the first part of the chapter. See, if I say about alkanes, first about other things, what you have to remember, alkanes are also known as first paraffins. Why they are known as paraffin? If I divide the word, it will be param plus affins. Affinis. Param means you can say little. Affins means affinity. So this is the name of paraffins. Generally, if I say about them, they are vaccine nature. They are generally vaccine nature, and they generally react with the oxidizing and reducing agent. This is not a big deal. Okay. So just remember this much general formula. You know general formula. We have already discussed CnH2n plus 2. Okay. And okay, let's start with the IUPAC. IUPAC we have done, so we'll not concentrate more on the IUPAC. We'll do 2 to 3 example only. Okay, first example I'm giving you. You have to tell me the answer, because we have spent a lot of time on the IUPAC and still you cannot do, then it doesn't make any sense to take a class. Yes. From which side I should do the numbering? Left hand side and right hand side. Yes, speak. Is anyone present in the class?
From left hand side, sir.
From left hand side. Okay. So one, two, three, four, five, six. Yes, what's the name? On the fourth position, we have this ethyl group. On the second position, we have methyl. This is called
Methyl group.
methyl. This is called ethyl. On
Ethyl.
the basis of alphabetical order, yes. Huh? Speak up the name.
4 ethyl.
Yes, 4 ethyl,
4-ethyl
2 methyl.
2-methyl
2 methyl hexane.
hexane.
Yes. One more example I'm giving you. Just tell me. Yes. Do the naming. Numbering left hand side from the right hand side.
So from left hand side.
Okay. From the
Left
left hand
hand.
side, we'll do the numbering. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Yes, this is isopropyl.
Yes, sir. Yes, sir.
Isopropyl, yes. And this?
Butane.
No. Either write it
Butyl.
isopropyl or write it methyl propyl. This is called methyl ethyl.
But yes,
Not, oh, sorry, not methyl ethyl. What would be the name?
So butane.
butyl.
Hmm?
Butyl.
Butyl.
Butyl. Just write for it. Then secondary butyl. It will be more correct. The name will be 5. Secondary butyl. Then 4
4-isopropyl.
isopropyl. And then 10 carbon. So we'll
Decane.
taking.
Decane.
Okay. Check. This is good. Okay. If I talk about isomerism, because we have discussed most of the portion of this chapter earlier also. So I don't think that we have to repeat it again and again. So we are doing a sort of revision. Okay. In alkanes, I'm making the structure. You have to tell me which type of isomerism is this. Yes.
Second one branch, sir.
No, no. These are isomers. Na? Which type of isomer?
Sir.
Yes.
Position isomerism.
Your screen is not visible to me.
This is
Your screen is not visible to me, sir.
my screen is not visible.
For me, I don't know, sir. What others?
Yes, rest people. Is my
Sir, it's
screen visible?
visible, sir. Yes, sir.
Uh, do one thing is leave the class and log in again.
Okay, sir.
Sometime it happens, maybe sort of glitch. Okay. CS3, CS2, CS2, CS3, and CS3, CH, CS3 at the bottom CS3. This is a sort of chain isomerism, if you remember. Chain isomerism. So if I'll say about the name of this compound, this is butane. This is isobutane. Remember?
Yes, sir.
Okay, I'm making CH3, CH2, 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 CH3. One is CH3, CH, single bond CH3, then CH2, CH3, then CH3C, above it CH3, below it CH3, right hand side it CH3. Yes. So tell me the name, first one.
Sir, it's pentane, sir. First one,
N,
pentane.
you'll write N pentane. Second one,
Isopent.
yes, isopentane. Third one,
Neopentane.
yes, neopentane. So we have three, iso, neo, and N-pentane. Okay, so these were the isomers we have discussed. Okay, let's discuss about the method of preparation. Method of preparation. First method is from unsaturated hydrocarbon. Unsaturated hydrocarbon. For the from unsaturated hydrocarbon bit, I'm talking about double bond and triple bonded. For example, we can say CH2 double bond CH2 when react with H2O, what will in the presence of nickel, comma platinum, comma palladium. Yes, Ni, comma Pt, comma Pd. What you will do? You will give one hydrogen to this carbon, one hydrogen to this carbon. So it will form CH3 single bond CH3. So it was ethene and this is ethane. We have to form alkane right now. Okay, same process CH3CH double bond CH2 plus H2 in the presence of Ni, Pt, Pd. It will form one hydrogen to this carbon, one hydrogen to this carbon. So it will form CH3, CH2, CH3. So we are forming what? Alkanes. Okay. So this reaction generally occur in the presence of Ni, Pt, Pd. However, if you are taking the nickel only, ordinary nickel, for example, I'm taking CH2 double bond CH2 plus H2 and we are using Ni at 523 to 573 Kelvin. We are giving the particular temperature. Okay. Or you can use a little above it, and it forms the same product, CH3 single bond CH3. So that this is called hydrogenation. This is called what? Hydrogenation of unsaturated hydrocarbons. It means hydrogenation means addition of hydrogen. So addition of hydrogen using what? Using ordinary nickel. This reaction is commonly known as Sabatier and Sandern's GERN reaction, or you can say reduction. Why we are saying reduction? Just because on adding hydrogen in any of the species known as what? Reduction. Addition of oxygen is called oxidation. Addition of hydrogen is called reduction. Hello. Five. Then next is second method is from alkyl halide. From alkyl halide, and right, the first method in alkyl halide we are using as Grignard reagent. So Grignard reagent is RMGX. Okay, RMG, this Grignard reagent is given by a scientist. His name was Victor Grignard. Victor Grignard, and on the basis of that particular scientist, the name is given as Victor Grignard. Okay. So the reaction how it occurs, that is RX. R here is alkyl group, X is halogen, plus Mg in the presence of dry ether gives out RMgX. So just let's see example in the present in the place of R I'm using CH3CH2. X is a halogen, I'm using Br. When it react with Mg in the presence of dry ether, what will happen? It will form CH3CH2 MgBr. This is called Grignard reagent. This is what we call Grignard reagent. And just because we are forming the this is not hydrocarbon, first we are forming the Grignard reagent. Now when this Grignard reagent react with water, what will happen? It will what will happen? This MgBr react with OH and it will eliminate out MgOH-Br and will form CH3 single bond CH3. Okay, this is called ethane. So sometimes the question can be asked like why the Grignard reagent is not kept, why the Grignard reagent is kept in the tight bottle. So the reason is just because it reacts with the water and it forms what? A hydrocarbons. So I'm giving you a few examples. Just give me 5 to 10 minutes. I'll come again. CH3, CH2, CH2, Br plus Mg. You need to complete the reaction till the hydrocarbon is formed. Second is CH3, CH2, 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 Br react with Mg in the presence of dry ether, Okay. Form the compound. Third reaction I'm giving you, that is instead of CH3 MgI directly reacting with the water. Okay, complete these reaction. I'm just coming. Just wait. Yes, completed. Am I audible? Okay. I'm making the product, you can see. CH3, CH2, CH2, MgBr. Then we'll put water in that. It will form CH3, CH2, CH3. And it will gives out MgOH, Br. Same in this reaction. CH3, CH2, 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 1, 2, 3, 4, 5. CH2, MgBr. Then we'll add water. It will give CH3, CH2, 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 CH3 plus MgBrOH. Then here CH3, okay, direct MgOH out. Then CH3 plus HCH4 plus MgIOH. So that is not a tough reaction, I think. Okay. Second method of preparation, let's talk. Second method of preparation is called Woods reaction. This is important reaction. Woods reaction. So if I talk about the Woods reaction, generally we take here as bromide or iodide, and this when the alkyl halide, which contain either bromide or iodide, when they react with the metallic sodium in the presence of dry ether, they form alkanes. Okay, what I said, alkyl halide when react with metallic sodium in the presence of dry ether, okay, it will form symmetrical alkane. Symmetrical alkane plus NaX, sodium halide. Okay, 2 molecule of sodium halide. So see the basic reaction I'll write, then we'll do the example. Rx plus 2Na plus XR. See this Rx and Rx is the same thing. Na is the metallic sodium. In the presence of dry ether, what will happen? One Na will take one X, one Na will take another X, and it will gives out what? It will gives out NaX, 2 molecule, plus R and R, these two R will combine, it will form R single bond R. So let's take an example. One example I will do, another example you will do. CH3Br plus 2Na plus BrCH3. Okay. In the presence of dry ether, they form CH3 single bond CH3 plus 2Na Br. Okay. So your reaction is CH3CH2I plus 2Na plus I CH2CH3 in the presence of dry ether. Tell me the product.
CH2, CH3, CH2, 2 NaI.
One CH3 is less, CH3, CH2, CH2, CH3. Okay, and then it's correct, 2NaI. Got it? Any problem in this Woods reaction?
No,
No? Okay.
no,
Let's
sir.
let's discuss about the mechanism of Woods reaction. Okay. So what will happen? First of all, this Rx, one of the Rx molecule react with the 2Na. It will form R negative, Na positive, Along with that, it will gives out one NaX. One Na will react with this X, and that will gives out NaX, while one R will react with the Na and form R negative NaX. Okay, this is called alkyl sodium. This is known as what? Alkyl sodium. Now this alkyl sodium will react with another molecule of Rx. Since we know that X is highly electronegative element, halogens are electronegative, so it will carry partial negative character, and R will carry the partial positive character.
Positive.
Okay, so this R negative portion will go to the R positive portion, and Na will take on the X. So it will form R plus NaX. Clear? Yes.
Yes, sir. Yes.
Okay. Next type of reaction is, so I think this is the third type or second type. Okay. First type from hydrocarbon was from Grignard reagent, and second was Woods reaction, and third type was Corehouse reaction. Corehouse reaction. So if I talk about the Corehouse reaction, what happened in this particular reaction? First, like for example, that we have discussed Woods reaction. That's Woods reaction gives us alkanes, but not in good yield. So generally, we used to react this alkyl halide, that is Rx, with the aluminum, with the lithium, in the presence of dry ether. This is alkyl halide. Alkyl halide, when react with the lithium metal in the presence of dry ether, it will form alkyl lithium plus LiX. This is approximately same. What was, see, there we were using sodium. Here we are using lithium. So alkyl halide will react with the lithium in the presence of dry ether, form alkyl lithium plus LiX. Now we will take this alkyl lithium. Now this two molecule of alkyl lithium react with CuI. This is called cuprous iodide. Cuprous iodide. It will form R2Cu negative Li positive plus Li. This is called lithium dialkyl copper. This is called lithium dialkyl copper, and this is known as Gilman reagent. Gilman reagent. You say Gilman reagent, some say. Okay. So still the main aim to form is alkanes. Alkanes are not formed yet. First, we are telling about the Gilman reagent, how it is formed. First, alkyl halide react with the metallic lithium. In the presence of dry ether, it was forming alkyl lithium. And this alkyl lithium again react with the cuprous iodide to form Gilman reagent, that is called lithium dialkyl copper. Now this lithium dialkyl copper react with alkyl halide again. See, RCuR, that is R2Cu Gilman reagent. Negative Li positive. When it react with another molecule of Rx, now I'm putting a dash over the R. It means there is a different R group here. Okay, so it will form, see how the reaction occurs. One of the R react come to this one, and here X will go out. So it will form R dash plus. One molecule of R remain with the copper, that is RCu. Then this Li will react with the X, that will form LiX. This is alkanes. This is called alkyl copper, and then lithium halide. Okay, clear this thing?
Sir, can you explain from the here?
From
So, so second point, sir.
second, see the here I'm taking two molecule of R. Okay, it doesn't mean that in the starting that I have formed one. So we can obviously, it's obvious thing that we don't have only one molecule of the compound. We have ton of molecules. So this I'm taking two molecule of lithium, this alkyl lithium, and this alkyl lithium is reacting with the cuprous iodide. When they react, they don't know, just because lithium is a metal, copper is also a metal. Okay, but just form for the compound which was formed was a sort of complex compound, and that compound is known as what? Lithium dialkyl copper. And this lithium dialkyl copper, we named it as Gilman reagent. Okay, and this Gilman reagent react again with the alkyl halide, which was taking in the starting. In the Woods reaction, we are reacting Rx plus 2Na plus XR. So 2Rx was also there. Here we have 2Rx, but first one Rx will react with the lithium to form alkyl lithium, which on again reaction with cuprous iodide forming the Gilman reagent. And then Gilman reagent again react with the alkyl halide, second molecule. So we'll get the unsymmetrical alkane. Getting my point? See, I'll give you one example. I'll do one example. See, example of this. First of all, I'm having CH3CH2Br. This is the example, okay? CH3CH2Br. This is called ethyl bromide. This ethyl bromide will react with the two molecule of lithium in the presence of dry ether. What will happen? Now, one lithium will take one Br. It will form LiBr. One lithium is left, will combine with this CH3CH2 Li. This is called ethyl lithium. Now this ethyl lithium CH3CH2 Li will again react with the CuI, cuprous iodide. I'm taking two molecule, so it will form a compound that is CH3CH2 CH3CH2. They both are combining with the copper, will carry positive charge, and what we have with this lithium as, oh sorry, this will have
Lithium.
negative charge, and we have lithium as positive charge here. Okay, then lithium will which is left, what is left in the compound? Then we have lithium and iodine, LiI. Okay, now this compound will react with the ethyl bromide. See, I'm taking this compound CH3 CH2 CH3 CH2. They are combining with the copper. It will react with CH3. So just because we want unsymmetrical, so I'm taking one second Rx as different. CH3 CH2 CH2 Br. This is propyl bromide. Okay, now how the reaction occur? See, this CH3 CH2 will go to this particular compound. Okay, this Li will react with the Br. The rest, these compound will remain as it is. So now see, first of all, what happened? That CH3 CH2 CH2. Now we get two CH2 and CH3 also. First thing formed, that is pentane. Then Li will react with the Br, it will form LiBr. then CS3, CS2, Cu. That is ethyl copper is remaining, so it will form ethyl copper. Now got it? How the reaction is occurring?
Yes, sir.
Okay. Clear, everyone?
Yes, sir.
Okay. Next method. That is called, I think, fourth method in this. What we are using. Writing here fourth reaction. That is the reduction. That is reduction of alkyl halide. Reduction of alkyl halide. See, alkyl halide when react with the react when not react, we can say when they are dissolved in solution of zinc, acetic acid, HCl, they give out haloalkene. Okay, for example, or you can say the metal when dissolved in the RX solution. Anything. Alkyl halide. We are taking alkyl halide in the presence of Zn/HCl. We are putting that Zn/HCl into solution. Okay, what it will form? It will form RH plus HX, or we can write like for example, we can write like Rx plus HCl in the presence of zinc. We can write like this. What will happen? Yes. How the reaction occur? The same thing above the
RH plus HCl, sir. RH
R
plus HCl.
plus HCl. That's it. Okay. So the main thing we can say, we only want this H. Okay. We only want this H. So for example, I'm giving example is CS3, CH2, CH. Here we have Br, then CS3. Okay, I'm taking 2 molecules of this compound. This is called bromobutane, but just Br is on second position, so we consider it as 2-bromobutane. Now this 2-bromobutane react with the 2 molecule of HCl in the presence of zinc. That zinc will take on both the Br. It will give out ZnBr2. ZnBr2 is gone. Okay. Instead of this, just write H positive, 2H positive. So we are writing HBr here. Okay. Now zinc will take both Br and it will form CS3, CS2, CS2, CS3. This is again a different method. Although this is not important, this is not in our syllabus also that much. Okay. This is important, what I'm telling you now. This one is important. That is third method from carboxylic acid. See, I'm telling you what we have discussed. First, we have discussed about the method of preparation from unsaturated hydrocarbons, in which we have discussed Sabatius-Anderson reaction. Then we have discussed from the alkyl halide, in which we have alkyl halide was having the part first Grignard reagent, then Wurtz reaction, then Corey-House reaction, then reduction to alkyl halide. Then third is from the carboxylic acid. So from the carboxylic acid, we are using first method that is called decarboxylation. Decarboxylation method. So what is the meaning of decarboxylation? Anyone can tell me? What is the meaning of decarboxylation? See, this is the process of the removal of a molecule of CO2 from any organic compound. When we are heating the organic compound, generally the CO2 get eliminated out. So that process known as decarboxylation. How it occurs? Let's see. So in decarboxylation, what we are taking any of the carboxylic acid, that is RCOH. When it was reacting with NaOH, sodium hydroxide, in the presence of CaO. So the mixture of CaO and NaOH is known as soda lime. The mixture of NaOH that is called soda lime, CaO and NaOH. Okay, this soda lime, when it reacts in the present at 630 Kelvin, it forms alkene RH plus Na2CO3. This is the method. How it occurs in the lab? What we take one copper tube. This is a copper tube. Inside copper tube, we have this sodium acetate. We have the sodium acetate, or you can use carboxylic acid. Okay, along with the soda lime. On continuous heating it will gives out methane gas. We collect the methane gas by this method. I think you have learned this method earlier also. Okay, so we are using this is called downward displacement of water. Downward displacement of water. Since methane will not dissolve in the water, so it will come at the top and water will be here filled. Okay, so this is a you can say a method of preparation in the laboratory also. Laboratory method of preparation of methane gas. Okay, so let's discuss about the example. Yes, we have to form the compound. What will happen? See, two molecule of Na, one molecule of C, two atoms of Na, three atoms of oxygen, one atom of carbon. They will form what? Na2CO3
Na2CO3.
and CH3 plus S remaining, that is called CH4, methane. Okay, so tell me the product fast. I'm writing the reaction. Yes. Yes, product.
CH3 plus Na2CO3.
CH3 plus Na2CO3. Very good. Clear? Okay. Second method is coal-based electrolytic method. Can anyone tell me what is electrolysis? Yes. What is electrolysis? Electrolysis is the dissociation of a molecule in the presence of.
Water into hydrogen and oxygen, splitting, sir. Is it?
See, that is splitting of water by the help of electric current. That is electrolysis of water. But if I'm saying only the electrolysis, it means the splitting of any molecule in the presence of current. If you're giving the current and the molecule is splitting, it means we are talking about the splitting. We are talking about the electrolysis. Okay,
Chemical.
so let's take an example. Two molecule of RCOONA. This is called sodium salt of carboxylic acid, or you can say sodium carboxylate. Okay, when it react with water in the press, and we are providing the electric currents, we are writing electrolysis here. So what will happen? The two molecule of R, they combine with each other and form R dash R. Along with it will form NaOH, two molecule. Then hydrogen and then carbon dioxide is eliminated in this reaction. So this is a method of preparation of alkanes by the help of carboxylic acids, but by the help of current main thing. So when we are using the current, or we are using the electricity to just dissociate of the molecule, that's why we are saying it as what? Kolbe electrolyting method. So if I say one thing, this particular reaction, Kolbe electrolytic method, this is the method which developed the organoelectrochemistry. There's a branch in organic chemistry that is called organoelectrochemistry. This particular reaction gives the foundation of this particular type of chemistry. Just because generally we use electric current for the dissociation of molecule in inorganic chemistry, but it's for the first time when we are using the electrolysis for the dissociation of organic compound also. That's why the new branches formed, that is organoelectrochemistry. Okay, so the foundation reaction is Kolbe reactions. Okay, let's do an example of Kolbe reaction. CS3COONA, two molecule plus two molecule of water in the presence of electrolysis. It will form, yes, it will form basic reaction. Just remember the basic reaction always. So see, basic reaction if you have written, then tell me the product of this reaction. Yes. What is the product? See, 2CS3 will combine with each other, CS3 single bond CS3. Along with that, Na will take one OH, NaOH. Two molecule of NaOH will be given out. Then I told you hydrogen gas. Then
CO2.
carbon dioxide. Yes, that's it. Okay, just remember this thing. Last method is, see, from carboxylic acid we had two, that is decarboxylation, called Kolbe electrolysis. Last method is, fourth method is by the action of water on beryllium and aluminium carbides. By the action of water on beryllium and aluminum carbides. So that is, for example, I'm taking Be2C, that is called beryllium carbide. So this beryllium carbide, when react with the water molecule, it will form CH4. Along with that, it forms hydroxide of beryllium. Same, Al4C3, that is aluminium carbide. When this react with water, 12 molecule of water, it gives out 3 molecule of methane and form AlOH whole thrice. Okay, so this is also a method. Some books have this method, some books don't have this method. I just told you, maybe I don't know from which book you are learning, so that's why I told you this method also. Let me check your book also. That is, we have Sabatier reaction, we have done alkyl head, we have done uh, from Grignard agent, we have done fatty acid, that is carboxylation, we have done. Okay, one more reaction is given in your syllabus, that is Franklin reaction. Franklin's reaction. If I'll say about this particular reaction, and this reaction same as we were doing in as they were doing in Wood's reaction. This is a type of same reaction. See, just in place of sodium, we are using what? We are using zinc. So two molecule of Rx when react with the zinc. The zinc will take both the Rx, that will form ZnX2, and both R will combine with each other. Okay, so just take up the example. For example, I'm saying CS3CH2 Br, two molecules react with zinc in the presence of same dry ether. Okay, dry ether and little bit of heat. Okay, now it will form what? The product will be
CH3 to CH3 CH2 CH2
CH3,
CH3
CH2,
plus
CH2, CH3 plus
ZnBr2.
ZnBr2.
very good. Both words correct. Okay, so they are generally see, you have to remember one thing: Wood's reaction and Franklin reaction. They both reaction are mainly used for preparation of alkane containing even number of carbon. So if the question is arises that reaction which is used for the even number of carbon, you can write like this. Clear? Clear?
Yes,
Yes,
sir.
sir.
Any of the reaction if you have doubt? Okay. If you don't have, then we'll start. See, the preparation is this much only. Let's start with the physical properties. Let's start with the physical properties. Okay. So those properties I'm telling you right now, you have to remember those properties only. Okay. Just give me 1 minute. Okay. So first thing what you have to remember. First thing what you have to remember that lower carbon compounds which have C1 to C4, which we have C1 to C4, they are generally colorless gases. C5 to C18, they are colorless liquid, and rest are colorless waxy solid. They're generally waxy in nature. Okay. Next thing what you have to remember, that is boiling point increases with increase in molecular weight, but decreases on branching, So if the number of carbon atom increases, then boiling point increases because we have to heat the particular compound. Okay, and more energy will be required just because the we have a big compound. You can say the molecular weight is more, so obviously that's obvious that boiling point will be more. But why there's a decrease in the on branching? There must be a reason. See what will happen. The wonderful force of it. 1 minute. Yeah, I just bite up my lip to it. Yeah. So, as the number of carbon atom increases in this branching, then the surface area was decreasing. The surface area was decreases. And when the surface area decreases, the van der Waals force of attraction also decreases. Okay. When the surface area decreases, van der Waals force of attraction also decreases. So let's see what exactly happened. We can take an example. See, CH3, CH2, 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 CH3, CH3, CH. Here we have CH3, then CH2, CH3, then CH3C, CH3, CH3, CH3. So if I talk about this particular compound, this is N-pentane, this is isopentane, this is neopentane. If I talk about the boiling point of this compound, that is 309.1 degree, and boiling point of this compound 301 degree, and boiling point of this compound is 282.5 degree. We are taking in the form of Kelvin. So first of all, tell me which one will have higher boiling point.
First one, sir. N
First
pentane.
one, just because no branching is there, it's written. Have given the boiling point, so you can easily tell by watching the boiling point. Just because the boiling, just because I have mentioned here, so you can easily tell that this particular compound having the higher boiling point. So if I'll not write the boiling point, how you'll recognize that this particular compound is having the higher boiling point? You'll see if the number of carbon atom is equal in all the compound, then see the branching. As the number of side chain increases, that means branching will increase. And if the branching will increase, the surface area of the compound decreases. And as the surface area decreases, van der Waals force of attraction also decreases and the boiling point decreases. So you can see in the first compound, second compound, and the third compound, the first compound is having the highest boiling point. Why? Because there is no branching. Second compound, you'll see that is 309 to 301 it came. So it means there's a branching. One branch, one methyl group is on the as a side chain. Branching is there. The boiling point decreases. So in the third case, you can see the boiling point again decreases. Just because two branches are there. Okay, so as the number of carbon atom increases, the boiling point increases. But if the number of carbon atom is same, but the branching is increasing, it means the boiling point will decrease. So we can write that boiling point is directly proportional to the surface area. It means more surface area, more boiling point, just because the molecular weight will be more. But we can also write boiling point is inversely proportional to the branching. Clear? Boiling point is inversely proportional to the branching also. So
Yes.
basically, if the branching increases, the intensity of van der Waals force decreases. So you can write if branching increases, then intensity of van der Waals force of attraction, van der Waals force of attraction decreases. Clear?
Yes,
Yes.
sir.
Okay. If I talk about the that melting point, so there is no such increase. Okay. Generally, the melting point of alkane also increases with the increase in carbon, but there is no regular trend. There is a no regular trend, or you can say there is an alternation in the property. Okay, so some compound having the higher molecular mass still have the less melting point. Some having the higher melting point. So we don't have a regular trend in the you can say in melting point. So wait. Sorry. Am I audible?
Yes, sir.
Okay. So what I said that there is no any clear evidence or clear trend regarding the increase of melting point of the alkanes. But just remember, as the number of carbon atom increases, the melting point also increases. Let's talk about the solubility. Let's talk about the third one that is main, that is solubility. So I told you one thing in this starting solubility, which are more like dissolved, like if you remember like dissolved like. What was the meaning of like dissolved like? Like dissolved like, it means polar
Polar solid.
solute. Yes. Speak. Polar solute will dissolve in.
Polar so- solvents.
Yes. And non-polar dissolve in.
No, non-polar
In
solvents.
non-polar solvent. So generally, the alkanes are non-polar in nature. Predominantly, we can say that these are non-polar in nature. So they generally are insoluble in the water, alcohol. But if I talk about the solubility in the organic compound which are non-polar, such as I'm talking about, such as petroleum products, or you can say ether, you can say benzene, you can say carbon tetrachloride. So they are soluble in it. So alkanes, just because alkanes are predominantly non-polar, so insoluble in water, or you can say alcohol, etc., but soluble in ether, benzene, CCl4, etc. So these in these particular compound it is easily soluble. Okay, clear?
Yes, sir.
Okay, next and last fourth is, we can say, density. See, density. Okay, what is the formula of density?
Mass by volume.
Mass by
Huh?
Mass
volume.
by volume.
Mass by volume. So if I'm saying the mass of the organic compound is increasing, so density will increase or not?
Yes, sir. It will increase.
It will increase. It means we can say density increases with increase in molecular masses. Although alkanes are lighter than water. Alkanes are lighter than water. Clear? So let's now, we have done with the preparation and physical properties. We'll move further to the chemical properties. But first, let's do some question. on the basis of whatever we have learned till now. Okay, so we have N-pentane, we have N-heptane, first, second, third, we have 2-methyl hexane, fourth, we have 2-methyl heptane, then fifth, we have 3,3 dimethyl pentane. Okay, so you have to arrange in the increasing order of boiling point. Increase it and then tell me.
N-heptane.
First one, the lowest boiling point.
Fifth one, sir.
Fifth one, sir.
Fifth one will have lowest boiling point.
Yes, sir.
Pakka. First see the number of carbon atom. First see the number of carbon atom. I told you the line was when as the number of carbon atom increases, the boiling point increases. Second concept was on increasing the branching. But first the number of carbon atom in this must be the same for the case of branching. But I don't think they have that same number of carbon atom.
So then it could be N-pentane.
First one, yes. Least N-pentane just because it is having the less number of carbon atom. Okay, then you see we have here heptane in the second one, and in the fourth one we also have heptane.
Yes, sir.
But before that, one more thing, we have methyl here. So it means number of carbon atom increased.
Yes, sir. Then we need to put an heptane.
Yeah. And we can see 3,3-dimethyl pentane. It means pent 5 carbon, 6, 7. So 7 carbon is also present. See, first write the number of carbon atoms which are present. In this particular compound, we have 5 carbon. In this compound, we have 7 carbon. In this particular compound, we again have 7 carbon. In this compound, again 7, 8. We have 8 carbon. And here we have 7 carbon. Yes. N-pentane is the first one. Then, just because of the second, third, and fifth, they all are containing 7 carbon, but maximum number of branching is present in the fifth one. So it will be 3,3 dimethyl pentane. Then we have 7 more left, that is N-heptane and 2-methylhexane. But in 2-methylhexane, we have branching. One branching is there. So it will be 2-methyl hexane. Then we have N-heptane. And the maximum number of carbon, that is last one, 2-methyl heptane. Got my point?
Yes, sir.
Confirm? Okay. Then tell me, question is, pentane and 1 chloropentane. Which one is having the higher boiling point?
First one's a pentane.
Okay. What about other? Yes. Anyone else?
Pentane only, sir. First one.
Pentane.
Pentane. How it can be pentane? Again, the same line.
Pentane, sir.
If molecular weight is more, it means more boiling point. See, pentane is present here, pentane is present here. But we also have chloro here. So if chloro is present, means chlorine weight must be added. So this will have more molecular weight. So if it have more molecular weight, it means more boiling point. Yes or no?
Yes, sir.
So how it can be pentane? Okay, I'm giving you one more example. 2-methylhexane and 2,2 dimethyl pentane. Yes. Which one is having the more boiling point? First think and then tell the answer.
First one, sir. 2-methyl.
Methyl hexane.
And why? Reason. What is the reason why 2-methylhexane is the correct answer?
Sir,
But what?
2,2-dimethyl has more branching than 2-methylhexane, sir.
Yes, it means in this compound less branching. And if less branching, it means greater surface area. And if greater surface area, it means greater van der Waal force of attraction and then more boiling point. More boiling point. Clear? Okay. Third, CH3Br and CH3I, which have more boiling point. Yes, speak fast.
So, methyl bromide has highest boiling point, sir.
Methyl
CH3I, sir.
Bromide.
CH3 ice.
Yes, sir.
CH3I will have more boiling point. What is the
Yes.
reason?
More number of
Atomic size.
Atomic size and weight.
Atomic weight, or you can say the molecular weight of this compound is more.
More.
If the molecular weight is more, it means boiling point will be more. See, CH3 is common, and you know that fluorine, chlorine, bromine, iodine have the more mass. Clear?
Yes, sir.
yes.
Okay. One more example. Hmm. I'll ask, just make the diagram. Okay, make the structures. And first see, you have to tell which one have the highest boiling point. First make the normal structure of this compound and then start doing. Then we'll go, after this example, we'll move further to the chemical properties. First, check out the number of carbon atom, okay? I think number of carbon atom is same in all compounds.
Yes, sir.
Okay, to make it less, more easy now, you can do one thing. Instead of this, make it here. 1, 2, 3, 4, 5. Yes, 6 carbon. Yes. Any answer?
They have highest boiling point.
Why?
No branch.
Number of carbons is same for all, but there is
Less
no
branching or no branching, you can say. Okay. What about the least boiling point?
C and D.
C and D. Yeah. A D will be the having the more. Okay, let's start with the chemical properties of the. Let's start with the chemical properties of the alkenes. Okay. Chemical properties of alkenes. So first chemical properties, just because we are talking about uh, hydrocarbons. So first thing we are taking it as substitution reaction. Substitution reaction. Okay, what is substitution reaction? We have learned in the lower classes. What is substitution reaction? No one knows the substitution reaction. See, when one of the element gets substituted by the another element, that is called substitution reaction. I think you have learned. Okay, guys are not revising your past things. Okay, so substitution reaction, a reaction in which a hydrogen atom of any of the hydrocarbon is replaced by any other group, in which hydrogen get replaced by any other atom or group. That is called what? Substitution reaction. For example, we are taking okay, order of reactivity, you can say. We are talking about halogenation. Okay, if we are talking about the halogenation, it means we have to replace the hydrogen by the halogen, and the order will be fluorine. We have the highest removal power, then second Cl2, then Br2, and then I2. This is the reactivity order. This is reactivity order. Okay, so let's do some reaction, that is CH4 plus Cl2. Methane, when react with the Cl2, this reaction either occur in the presence of Cl2 or at 520 to 670 Kelvin. Okay, it will, one of the hydrogen will react with the Cl, form HCl, another will form CS3Cl. This is called chloromethane. Okay, again this CS3Cl can react with the Cl2, H nu, or same temperature, you can say. One of the hydrogen will react with the Cl, forming HCl. One more hydrogen, so it will be CH2Cl2. 2Cl, it means dichloromethane. Again the CH2Cl2 react with the Cl2 in the presence of H nu or 520 to 670 Kelvin. It will form CHCl3 plus HCl. This is called trichloromethane. And this trichloromethane is also known as what? Chloroform. Then again CHCl3 react with the Cl2 in the presence of H nu 520 to 670 Kelvin. It will form CCl4 plus HCl. This is called carbon tetrachloride. Okay, right now I'm taking Cl. You can use Br, you can use iodine, you can use any of the reaction. Okay, but for the fluorination, I'm using chlorination. For chlorination, bromination, iodination, you can use this method. But for fluorination, it means addition of fluorine, we use a reaction that is called Schwarz reaction. See, all of you just revise today's class. Probably I'll complete alkane today. I'll try to complete the alkane. If it will complete, then it's good, or rest. Tomorrow it will complete. Okay. Okay, fluorination, it means when we are reacting with the, so in this particular reaction, Schwarz reaction, what will happen? CH3CH2Cl, that is chloroethane. They react with the Hg2F2, that is mercurous fluoride. Mercurous fluoride, it forms two molecules of CH3CH2F, that is called fluoroethane, plus Hg2Cl2, mercurous chloride. Okay, so generally fluorination occur when metallic fluoride react with haloalkanes, or you can say alkyl halide. So this reaction is called Schwarz reaction. This is important. Remember this. Clear? Next, mechanism of the reaction, that chlorination one. Okay, so first step of reaction is chain initiation. Chain initiation reaction. For the initiation of reaction, see what will happen. Now the Cl2 Cl2 was reacting. So at 520 to 670 Kelvin or at UV light, what will happen? Homolytic fission happen. So if you remember, homolytic fission leads to the formation of are you guys revising or not? Free radicals. It forms what? Free radicals. Now this free radical will react with the methyl group. So this step is known as chain propagation. Okay. So this CH4, we have methane molecule, and this Cl free radical will react. So what will happen? Cl free radical will react on the hydrogen atom, and this bond will shift to this side. It will form methyl free radical along with the HCl. This is called methyl free radical. So now methyl free radical is formed. Now in this step, what will happen? The methyl free radical, see, one free radical is left here and one free radical is left here. These free radical react. This CH free radical, then Cl free radical, they both combine, or you can make arrow like this also. CH3 free radical plus Cl, or this is chain propagation. So just propagate it, don't break it. So we have another molecule of Cl. Now Cl free radical attack on this Cl, this again go out. So it will form C, H, 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 and here we have Cl, then Cl free radical again. Now the Cl, last step is chain termination. Third step, that is chain termination. Termination means now you have to terminate or close the chain. Now the CS3 free radical remaining one will react with the CS3 free radical, or CS3 free radical will react with the Cl free radical, or Cl free radical will react with the Cl free radical. So it will form CS3 CS3, it will form CS3 Cl, it will form ClCl. Okay, so this is the mechanism how the reaction occur. First is, so you can see the step, first one is the chain initiation. For the initiation, we have temperature or the UV light, which dissociate the Cl2 molecule and form chlorine free radical. Now chlorine free radical attack on the methane, then it will gives out the methyl free radical along with the HCl. Now this methyl free radical react with another molecule of chlorine and form methyl chloride plus chlorine free radical. Now the chlorine free radical will react with the chlorine free radical, form Cl2. Chlorine free radical react with the methyl, forming methyl chloride. Methyl free radical react with the methyl free radical, form ethane. So this is a mechanism process. Okay. So next, let's start with the second substitution reaction, that is called nitration. See, the process of removal of hydrogen by NO2 group. So this is called nitration. For example, we have CH3, this is called methane, CH4, but I'm writing one H separately. When it react with HNO3, fuming HNO3, what will happen? See, I can write it as OHNO2, HNO3H, NO3. Okay, this OH will react with the H, it will form H2O. And remaining NO2 portion will go on CH3, it will form CH3NO2. Clear? Getting my point? Yes or no?
Yes, sir.
Yes,
Okay.
sir.
Then sulfonation, third is sulfonation. Sulfonation we react with by, in which the H's get replaced by SO3H. H is replaced by SO3H. Generally, this reaction occurs in the presence of SO3. So see how the reaction occurs. It is like CCS3, CS3, CS3. I'm taking tertiary. Okay, it reacts with the H2SO4 in the presence of SO3 at 675 Kelvin. So H2SO4 can be written as OH or SO3H. See, H2, SO3 plus 1 O, SO4, H2SO4. Now this OH will react with the H and form H2O, and this SO3H remaining will join here. So it will be C, CS3, 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 and we have here SO3H. The name of the compound is 2-methyl propane 2 sulfonic acid. So this is called what? Sulfonation. Okay. So here why I'm taking 3 degree, or you can say just because substitution of hydrogen is more convenient in 3 degree than 2 degree than 1 degree in case of sulfonation. Okay. Next method, next type of reaction is we have oxidation reaction. What we have? We have oxidation reaction. Okay, what is oxidation? What is oxidation? What is the meaning of oxidation?
Loss of electrons.
Loss of electron. What else?
Adding of
Adding of oxygen. Basic thing is addition of oxygen. So when alkanes, see, no, okay, wait. We are dividing oxidation into three categories. First category I'm saying as complete oxidation. Complete oxidation, or you can say it as combustion. Second is incomplete combustion. Third one is catalytic oxidation. Catalytic oxidation. Okay, so let's start with the complete combustion. Complete combustion. So if I talk about the complete combustion, it means we have a sufficient amount of oxygen is present and the carbon compound will burn into CO2 and H2O plus plus heat. Okay, so reaction, for example, I'm saying CH4 plus 2 molecule of O2 gives out CO2 plus H2O, and here delta H is equals to delta CH naught. Okay, I'm writing delta CH naught is equals to minus 890 kilojoule per mole. So you have learned this in thermodynamics, I think. Delta CH is enthalpy of combustion, and if I'm writing not here, that is standard enthalpy of combustion. And if the standard enthalpy of combustion value is in negative, it means I'm talking about the exothermic reaction. So here minus 890 kilojoule per mole energy is released. Okay, so we have this complete combustion, and you can write complete combustion basic reaction as CnH2n plus 2 plus 3n plus 1 upon 2 by O2 gives out n number of CO2 plus n plus 1 number of H2O. So this is a basic reaction. Just write the value of n and the reaction will be balanced. Okay, so this is complete combustion. And in complete combustion, you have to remember the large amount of heat is evolved, or you can say liberated. And let's talk about the incomplete combustion. Today we'll do oxidation last. Incomplete combustion. In case of incomplete combustion, we have a limited supply. We have a limited supply of air, or you can say limited supply of oxygen. So when there is a limited supply of oxygen, instead of CO2, CO is formed. So reaction can be like CH4 methane is reacting with 3 molecule of O2. It is forming 2 molecule of CO plus 4 molecule of H2. Okay, if limited supply of oxygen is present, then this product will form. If limited amount of carbon is present, this is limited, and reacting with the oxygen, it will form C plus 2 molecule of H2O. This C is called carbon black. So sometimes you have to see which is in the less amount. Okay, last one is oxidation. Third one is catalytic oxidation. We'll start catalytic oxidation next classes because it's quite big. Okay, just complete. We'll do 4 to 5 reactions. Okay, catalytic oxidation, it means the oxidation is occurring in the presence of a catalyst. For example, I'm writing 2CH4 methane is reacting with the O2. Here, this is occurring in the Cu tube, copper tube. at 100 atm of pressure and 573 Kelvin of temperature. It is forming what? Alcohol. It is forming what? Alcohol, that is methanol. So this is called, the catalyst here we are using is copper tube. Copper. Okay. Next thing we can use, like CH4 is again reacting with the O2, but now the catalyst is MO2O3, molybdenum oxide. And on heating and at high pressure, it is forming HCHO plus H2. This HCHO is methanol. So depending upon the catalyst, the reaction occur. That is known as catalytic oxidation. It can directly convert into the carboxylic acid, it can directly convert into aldehyde, it can convert into the alcohol. So this much is enough for the today. Revise this. Tomorrow we have aromatization reaction, we have isomerization reaction, uses and stereoisomerism in this alkene portion. And that alkene portion will be done. We'll start alkene from the next week then. Tomorrow I'll complete this. Okay, so see you in the next class. Just revise this first. Okay, I want you to revise this much at least. We have done a lot today. Just revise it. This much is enough for the today. Thank you. You can leave the session.